All right, so are you ready to dive into the world of mobile app reliability?
Always ready for a deep dive, yeah.
Today we are looking at Engineering Reliable Mobile Applications, a book written by engineers at Google.
Okay.
And we're really trying to understand the unique challenges of building these mobile apps that handle, well, billions of users.
Yeah, it's a completely different game than traditional server-based systems.
Exactly.
Completely.
Yeah, it's a whole other world. And what I think is so interesting about this book is it really gives you a behind the scenes look at, what goes into actually making these apps work reliably.
Totally.
I mean, we all rely on them every day,
Yeah.
right? I mean, think about it. We've all had those moments where your phone dies
Oh, yeah.
or an app crashes or freezes like the worst possible moment,
The
like
worst.
right when you're about to, pay for
I'll
something.
send that email.
Yeah, or send that important message.
Ugh, so frustrating.
So, in this deep dive, we're really going to uncover how those annoying glitches happen,
Okay.
and more importantly, what developers can actually do to prevent them.
Yeah, and here's something I think is really interesting.
Okay.
We often talk about the massive scale of data centers,
Right.
but the network of mobile devices out there is actually way bigger.
Oh, for sure.
You're talking about billions of phones,
Mm.
each with its own unique hardware, software versions, network conditions.
It's mind-boggling when you think about it.
It's a recipe for absolute chaos if things aren't designed carefully.
Yeah. Well, and this book really gives us a glimpse into how Google tackles those challenges
Yeah,
to keep their apps, you know, running smoothly.
right.
So, first things first, like, how do we even define availability when it comes to mobile apps?
Oh, that's a great question. And it's not as simple as just checking if a server is up, you know?
Right.
Because in the mobile world, availability is all about the user's experience.
Okay. So from a user's perspective, an app is essentially unavailable if it crashes, freezes, or just, doesn't respond the way you expect it to.
Totally.
Right.
Yeah. The book introduces this concept of what they call service level indicators, or
Yeah.
SLIs for short. Think of them as specific ways to measure how well an app meets user expectations. It's all about those user interactions.
Okay.
For example, how often does a search function return the results you're actually looking for?
Right.
And how long does that take?
Oh, yeah, that's a good point.
These SLIs, they help developers really see the app through the eyes of the user.
Okay, that makes a lot of sense.
Yeah.
So instead of just tracking if a server is up, you're actually looking at the entire user journey
Right. Okay.
within the app. But with billions of devices out there, how do you even begin to monitor all of that?
It's a huge question, right?
Yeah.
Well, the book talks about this need for both white box and black box monitoring.
Okay.
White box monitoring is kind of like peering into the inner workings of the app itself. It's about analyzing data from within the app, like those crash reports you mentioned,
Oh.
or even custom metrics that track what the code is actually doing.
So it's kind of like having a detailed log of everything that's happening
Precisely.
under the hood.
Yeah, but that's only half the story. Black box monitoring is more like observing the app from the outside,
Hmm.
almost like a user would,
Okay.
to see if it's behaving as expected. This helps catch those sneaky issues that might not show up in that internal data.
Give me an example. How would that work in practice?
Sure. Imagine a server is sending the wrong data, which makes the app display something incorrectly.
Okay.
That error might not actually trigger a crash report in the white box monitoring system.
Oh, interesting.
But with black box monitoring, you'd see that the app isn't functioning as it should.
From the user's perspective.
Exactly.
Ah, I see. So it's like having two sets of eyes,
Yes.
one looking inside the app
Right.
and another watching from the outside.
Uh-huh.
This way, you're more likely to catch any problems that might slip through. This makes me think of something else the book mentioned, the tyranny of the long tail.
Yes.
What do they mean by that?
This is a crucial concept, especially when you're dealing with the scale of mobile apps.
Okay.
The Google engineers share this story about adding a mobile component to Google Play services and discovering surprisingly high failure rates.
Wait, Google Play Services, that's like the foundation of Android, right?
Right.
How could that be failing so often?
It comes down to the sheer diversity of the mobile ecosystem.
Okay.
You have countless device models, different operating systems, various app versions.
Yeah.
It creates this incredibly long tail of potential failure points.
So you're saying that a small percentage of devices running very specific configurations could actually be causing a majority of the problem.
Exactly.
Bro.
And that's why just focusing on individual errors or events,
Yeah.
might not give you the full picture. The Google team realized they needed to change their approach and start measuring success in terms of device hours, good performance, rather than just looking at those individual events.
So instead of getting bogged down by every single error, you look at the overall health of the app across a vast user base.
Yeah, exactly.
Right.
It's a fundamental shift.
Okay.
It helps you focus on ensuring a consistently good experience for the majority of your users,
Right.
rather than chasing down every single, isolated incident.
That's a pretty clever way to look at it. But I'm guessing even Google isn't immune to the occasional mobile app mishap,
Well,
right?
absolutely not.
Even with all these strategies in place.
No, not at all. In fact, the book shares a story about, of all things, a Google Doodle causing the mobile search app to crash.
Hold on, seriously. Those cute little illustrations on the Google homepage
I know, right?
brought down the mighty search app.
It sounds unbelievable, but it happened. Apparently, this particular doodle was missing a crucial configuration field. So as the doodle rolled out globally, hitting different time zones at midnight,
Yeah.
the search app started crashing for users in those regions,
Oh, wow.
like clockwork.
That's fascinating how something that seems so simple on the surface can have such a cascading effect. So how did Google figure out what was going on? Did they fix it quickly?
Well, they noticed a spike in errors,
Right.
but there was a catch. The client code was actually caching the doodle configuration. This meant that the bad data was sticking around on devices,
Oh.
even after the server-side issue was fixed.
So it was like a delayed reaction?
Yes.
That actually amplified the problem.
Exactly.
Ouch. So what did they learn from this doodle disaster? What were the takeaways?
Well, this incident highlighted the critical need for both client-side and server-side fixes.
Right.
Even if you patch the app,
Yeah.
there will always be users on older versions who don't get the update right away. You need to protect them on the server side as well.
It's a good reminder that you can't just rely on users to update their apps
No.
to solve problems. You need
Yeah.
to have those safety nets in place.
Exactly. And it underscores the importance of what we call defense in depth,
Mm-hmm.
having multiple layers of protection.
Right.
That way, a single point of failure won't bring down the entire system.
Okay. Well, this is starting to paint a clearer picture of how complex mobile app reliability really is.
Yeah.
It's not just about writing good code, it's about understanding all these interconnected pieces and how they can impact each other.
You've hit the nail on the head,
Yeah.
and we've only just scratched the surface.
Oh.
Buckle up, because there are even more fascinating challenges and solutions to explore when it comes to building reliable mobile apps at a massive scale.
All right. Well, I'm all ears. Let's hear what other insights this book has to offer.
Okay, so we talked about that tyranny of the long tail
Yeah.
and how even a small percentage of devices can cause, a big headache.
Yeah.
But what about those times when it's not just a few devices acting up,
Right.
but like a huge wave of users all doing the same thing at the same time?
You're talking about what we call thundering herd problems.
And they can be a real nightmare for mobile app developers.
That sounds pretty intense. What causes these thundering herds?
Well, one common culprit is something we've touched on before, synchronization.
Okay.
Mobile devices often rely on these external cues like clock times or network changes
Right.
to trigger certain actions.
Yeah.
So imagine your app is designed to, say, check for updates at midnight.
Okay.
Seems harmless enough.
Right. But I'm guessing that's not so harmless when you've got millions of users all doing it at the exact same time.
Exactly. It creates this massive spike in traffic that can just bring your servers to their knees.
Oh, wow.
And it's not just limited to updates.
Okay.
Any task that's scheduled for a specific time
Yeah,
can trigger a thundering herd if enough users are all doing it in sync.
I see. So it's like a time bomb waiting to go off. But surely Google has figured out a way to defuse these ticking time bombs, right?
Well, it's not always easy. The book describes this situation where the Google team noticed this unusual pattern in their data,
Okay.
a double plateau in the registration rate for their messaging service.
Okay. Remind me, which messaging service are we talking about here? I know Google has a few.
Oh, right. This was Firebase Cloud Messaging,
Okay.
or FCM, for
Oh,
sure.
right.
It's what they use for things like push notifications.
Right, right.
Every time a user installs or updates an app that uses FCM, their device has to register with the service.
Okay.
So back to this double plateau, what was causing it? Well, it turned out that a seemingly minor code change during an app update
Yeah.
was triggering a surge in these FCM registrations.
Okay.
As users updated the app, their devices would all try to register with FCM at roughly the same time,
Got it.
creating this unusual pattern in the data.
So even a small change, multiplied by millions of users, can have this huge ripple effect.
Yeah.
It's like those butterfly effect scenarios, right? A
Yeah.
tiny flap of the wings in one place can cause a hurricane somewhere else.
That's a great analogy. And synchronization issues aren't the only cause of these thundering herds.
Okay.
The way traffic flows across the internet can also contribute to these problems.
Okay, now I'm really intrigued.
Yeah.
How does traffic play into this?
Well, think about the physical location of, mobile users
Right.
and cloud infrastructure.
Yeah.
The biggest cloud providers often have their servers concentrated in certain regions, like North America or Western Europe,
Right.
where it's cheaper to operate.
Right. Because of
Yeah.
things like electricity costs
Exactly.
and the availability of data centers.
Right. But mobile users are everywhere.
Yeah, they are.
So you might have a situation where an app is incredibly popular in a region with very limited cloud capacity.
Right.
Suddenly, you have a surge of traffic from that
Hmm.
region,
Yeah.
and the local infrastructure just can't handle it.
It just can't keep up.
Right.
So it's not just about the total number of users, but also about where they are and how that aligns with where your servers are.
Exactly. That geographic distribution of users can make a huge difference.
Yeah, that makes a lot of sense. Are there any real-world examples of this in the book?
There's a really interesting one involving Google Now.
Oh, yeah?
The service that provides those personalized updates and recommendations.
Oh, yeah, Google Now. I use that all the time. What
Yeah.
happened?
Well, the team was working on a feature to deliver real-time updates for sporting events.
Oh.
And as you can imagine, these events are incredibly popular. They have global audiences.
Yeah, I can see where this is going.
Right.
Big game, millions of fans checking for updates, recipe for a traffic jam.
Exactly. Even though they planned for the initial surge of traffic when each update was sent out,
Right.
they hadn't fully accounted for the responses coming back from the devices in all these different regions.
Ah, so the traffic generated by sending the updates was spread out, but the responses all converged on specific data centers,
Right.
causing a bottleneck.
Exactly. It highlights what the book calls asymmetric topology effects. The fact that traffic flow isn't always balanced.
Right.
It's something that can really catch you off guard if you're not careful.
So we've got time synchronization issues,
Right.
geographical traffic patterns. All these things can contribute to these thundering herd problems.
Yeah, it's a multifaceted challenge.
So what are some strategies that Google has used to mitigate these issues? What have they learned?
One of the biggest takeaways is the importance of proactive design.
Okay.
You can't just cross your fingers and hope these problems won't happen.
Right.
You have to design your apps from the ground up with resilience in mind.
So it's about anticipating those potential surges in traffic and making sure your code can gracefully handle them.
Exactly. And it goes beyond just the app itself.
Okay.
It's about collaborating with the teams responsible for the server infrastructure,
Right.
to make sure there's enough capacity to handle those peak loads.
Yeah. It's like that saying, an ounce of prevention is worth a pound of cure. It's much easier to build in safeguards from the start than to try and scramble when things are already going haywire.
Couldn't agree more. Now, when it comes to preventing those clock-induced synchronization issues,
Right.
there are a few key strategies they recommend.
Okay.
One is to avoid scheduling tasks at specific times unless it's absolutely necessary.
So instead of having everyone's app check for updates at midnight sharp, you kind of spread those requests out over a longer period.
Exactly. That way you avoid having millions of devices all hitting the server at the exact same moment.
Makes sense.
Another technique is to use what they call smear factors.
Okay.
Essentially, you introduce a bit of randomness into your scheduling.
Okay, so instead of everyone checking for updates at midnight,
Right.
it's more like they're randomly assigned a time within a window.
Exactly. It's a simple but effective way to smooth out those traffic spikes and prevent everything from happening all at once.
I'm seeing a pattern here.
Yeah,
It's all about anticipating potential issues
right.
and building in flexibility and resilience.
Absolutely. Building reliable mobile apps at scale is a complex challenge.
It is.
But by understanding these unique dynamics of the mobile world and applying the right strategies, it's definitely achievable.
Yeah.
But there's one more tool in the arsenal that I think deserves its own segment. Feature flags.
Okay.
They play a crucial role in mitigating risk and ensuring a smooth rollout for these new features.
Okay, feature flags, I know they're important,
Yeah.
but I'm a little fuzzy on the details.
Yeah.
Let's unpack that in the next segment.
That was good.
Okay, so feature flags.
Yeah.
I know they're a big deal in the mobile app world, but I'm not totally sure I understand why, like
Well,
what makes them so essential for reliability.
Okay, well, feature flags are all about control.
Okay.
They give developers the power to uh, separate code deployments from feature releases.
Okay.
So it's like having a secret weapon
Okay.
that lets you push new code to users' devices,
Right.
but keep it hidden until you're actually ready to unleash it.
Yeah. So it's not just about deploying code. It's
Mhm.
about having a fine-grained control over when and how that code actually goes live.
Exactly.
That's pretty interesting, but how does that translate to improved reliability?
Well, think about it this way.
Okay.
Feature flags, they give you this, like, safety net.
Hmm.
You can gradually roll out a new feature to a small percentage of users, monitor how it performs in the real world,
Right.
and then you can slowly increase the rollout if everything looks good.
And if something goes wrong, you can quickly disable the feature
Right.
without having to push like a whole new version of the app.
Exactly.
Yeah, that sounds incredibly useful, especially when you're dealing with millions of users.
Yeah, you don't want to break things for everybody.
Right, exactly.
It minimizes the blast radius of any bugs that might slip through
Right.
and allows for faster iteration and things like that.
That makes sense.
The book also highlights how powerful feature flags are when they're combined with A/B testing.
Right, A/B testing, where you're comparing different versions of a feature to see which one performs better.
Exactly.
It's like running a science experiment
Yeah.
with your user base.
Yeah, exactly.
Okay.
And with feature flags, you can really easily control which users see which version of a feature,
Right.
making A/B testing much more efficient and reliable.
It takes the guesswork out of optimizing the user experience.
Exactly.
So it sounds like feature flags are they're kind of a must-have these days.
I'd say they're non-negotiable at this point.
For any development team that's serious about reliability and building great mobile apps.
Absolutely.
Yeah, this whole deep dive has been a real eye-opener, honestly.
I'm glad to hear that.
I'm really walking away with a whole new understanding of the complexities and challenges of building reliable mobile apps.
It's a whole different world, right?
Yeah, it is, and at scale.
Yeah.
So, what are some key takeaways you want to leave our listeners with?
Well, I think one of the biggest things to remember is that mobile app reliability, it isn't just about like the technical side of things.
Okay.
It's a cultural shift.
Okay.
It requires a proactive mindset, a commitment to building in these safeguards, and a willingness to constantly learn and adapt
Right.
as the mobile landscape evolves.
It's really about seeing the bigger picture.
Yeah.
And understanding how everything is connected.
Yeah.
And always striving to improve that user experience.
And got it.
Yeah, well said.
I think next time you open up an app on your phone,
Yeah.
just take a moment to think about all the effort that goes into making it work so seamlessly.
It's kind of mind-blowing.
To all the developers out there building those apps that we all rely on every day,
Yeah.
keep these principles in mind.
Keep them in mind.
Your users will definitely thank you.
They will. And to our listeners, keep those questions coming. You can share your thoughts and experiences online using the show's hashtag.
Yeah, we'd love to hear from you.
We would. Until next time, stay curious and keep exploring the world of mobile app development.
See ya.